All right, everyone. So we're on day 2 of antiderivatives, so section 4.1. Um, just another quick shout out or announcement here that you'll have your quiz on this on Friday. Please continue to reach out to me and let me know if you have questions or anything with your work so you know that you're ready for that. Um, Today is going to be pretty similar to yesterday. The only difference is on some of the problems, they might be a little bit more quirky or complex. There might be like one or two extra steps we have to do to this. But the point here is to just kind of take it step by step through the week and try to make the problems a little bit more complicated each day. Okay, so your assignment today is down here 7 to 10 and then 21 to 24. Um, as we get deeper into these problems, these integral or antiderivative problems, it's going to be important to kind of think about a few steps. Um, One is if you can simplify before you start taking the integral, make sure you simplify. And that means distribute, multiplying, replacing radicals with exponents. We did a little bit of that yesterday. Dividing is something we'll do today. Um, and just make sure no negative exponents are in your final answer. Again, we talked about that yesterday, and also checking your work. So working backwards from your answer to get the derivative, okay? So again, I'll go through 3 examples today, and I'll try and tie them to a problem that you're doing on your assignment today. So this one would be similar to number 9 on your assignment. And again, just at the top of your notes or somewhere, make sure you have this somewhere where you can see it. This is our basic power rule that we're going to be working with all week this week, and we talked about this yesterday. Okay, so the first one says find the antiderivative of square root of x plus 1 half or 1 over 2 square root of x dx. Okay, so first things first, let's change these radicals to exponents so that way it'll help us use the power rule. We're not taking the integral yet, we're just rewriting it. So this first part would be x to the 1 half. Okay, what I'll do with this second one is I'm going to change this to x to the 1 half, but it would be a lot helpful if we can start by bringing it up to the numerator, okay, because that's going to help us take the power rule. So I'm going to make this x to the negative 1 half, because I brought it up to the numerator, over 2. Okay, hopefully everyone got that. I just took this in the denominator, brought it up to the numerator, and when I do that, I have to make my exponent negative, okay, yeah, with respect to x. Okay, the reason I did that is it's going to allow me to use the power rule through this, okay? So this is going to equal, this would be x to the 1 half plus 1 would be 3 over 2. And if you're wondering where I'm getting any of that from, it is 1 half plus 1. So all I'm doing is finding common denominators to get 3 over 2. Okay, that's how I got that. Okay, and then over, let's see, that would be 3 over 2 in the denominator because n plus 1. So 1 half plus 1 is 3 over 2. Plus, this is going to be x to the negative 1 half plus 1 would be positive 1 half. And then here's where it gets a little different. In the numerator, I still want my n plus 1, but I have a 2 down here already. So I'm going to leave my 2 there, and my n plus 1 is going to be negative 1 half plus 1 is positive 1 half. And then I have my constant at the end. Okay, so just to jump back on that middle one, negative 1 half plus 1 got me to 1 half. Negative 1 half plus 1 got me to 1 half, but I have to multiply it by this 2 that's already down there. Okay? All right, so this is essentially it, but we have to simplify here. So like we talked about yesterday, if you have a fraction in the denominator, let's multiply by the reciprocal. So this is going to be 2 over 3, so it'd be 2 x to the 3 over 2 over 3. Okay, so took the reciprocal, ended up with this. Keep my x's in the numerator. This would become plus x to the 1 half, and then 2 times 1 half is just 1, right? Because those 2's cancel, so it's over 1. I don't need to write over 1. Plus c. okay? And I encourage you, just because I want to save some time on this video, but I encourage you on your own time, if you were to take the derivative of this, you would end up with this, okay? So this is what I'm going to box as my final answer, okay? All right, let's do two more examples. This one's similar to number 22, okay? Really the only thing here is I wanted to show this to you guys because we have three terms in the numerator, one term in the denominator. When we see that, let's rewrite it so that this x to the third gets divided out by each of these. So this is the same thing as 4 over x to the third plus 7x over x to the third plus x to the fourth over x to the third dx, okay? And why does that help us? Why did we do that? The reason is because it's going to help us, it's really going to help us get rid of these denominators. So another way of rewriting this would be 4x to the negative third plus 7x to the, let's see, what would that be? If this was 1 and this is 3 in the denominator, remember we subtract exponents when we're dividing, okay? So 1 minus 3 is negative 2. 7x to the negative 2, okay? And then plus 4 minus 3 is 1, so x to the first dx. I'm just going to put a 1 right there so we know what that is, okay? So now we're ready to take the antiderivative because we have everything in powers, okay? So I'm going to say, keep my constant, 4x, n plus 1 would be negative 2. N plus 1 would be negative 2 at the bottom. Remember, this is my n. Plus 7x to the negative 1 over negative 1, right? Because negative 2 plus 1 gives me negative 1. Plus x to the 1 plus 1 is 2 over 2 plus a constant. All right, we're almost there. We just have to get rid of these negative exponents and kind of simplify some of these positive negative signs here. So what this is going to end up being is 4 divided by negative 2 is negative 2. I'm going to keep my positive exponent. I'm going to take my exponent and make it positive, put it in the denominator. Okay? Negative 2 is in the numerator. Make it positive by putting it in the denominator. Okay, so this is going to be, I've got a negative down here, so I'm going to pull that out front and say 7 over x to the positive 1. And then we're going to keep this. There's not much we can do with that. X to the second plus, over 2 plus c. And looks good. I don't think there's anything else I can simplify here. So this is my final answer. Okay? All right, one more example and you guys will be on your way here. So this is a big one because we haven't really we haven't done anything similar to this at all in the last 2 days. So this is similar to assignment number 24. And notice the issue we have here is we have this whole expression x squared plus 1 all raised to the second. So what do we do with that exponent on the outside there? Okay. So what we can do when you see that is, let's go back to our steps. Those steps that you wrote down, let me bring them back out on the camera here. When we're simplifying, if there's an opportunity to distribute or multiply, let's do that, okay? So I'm going to turn this into the antiderivative of x squared plus 1 times x squared plus 1 dx. The reason I did that is because there's 2 of them, so I wrote it twice. Okay? We want to use our power rule here, but first step, we're not done simplifying yet, right? We have to multiply this out because that's going to give us a nice clean expression where we can use a couple power rules. So this is the same thing as taking the antiderivative of x to the fourth, right? Multiply the first, plus x squared gives me plus 2x squared, and then 1 times 1 is 1. Okay, so now this should look really familiar because we've done a bunch of these over the last day and a half. Now we can take the antiderivative of this. So this is going to be x to the 5th over 5. This is going to be 2x to the 3rd over 3. This is going to be x, and then we're going to have a constant at the end. There's nothing I can divide out. There's no negative exponents. I'm done. Okay, I went a little bit faster through that third one. I'm hoping at this point you kind of know where this power rule is coming from, how to get from here to here, for example. If that's still a problem, please reach out to me and let me know. Again, work through that assignment today. Do your best on it before you check the answers. Don't just, obviously don't just copy the answers or write down the answers, because you want to make sure that you understand it for this quiz on Friday, okay? Let me know if you need help.